Hey everyone, welcome to lesson 3.3, where we're going to start to talk about factoring and more specifically common factoring and grouping. So let's take a look. Factoring is the process of breaking down a number, an expression, or a polynomial into a product of smaller, simpler factors that, when multiplied together, equal the original number or expression or polynomial. So let's fill these in. So we want to start thinking of factoring as the opposite of multiplying polynomials. In the last couple of lessons, we expanded polynomials. And when we start to think about factoring, we want to break them apart. But let's start with a number. Consider the number 32. There are a few different combinations of smaller numbers that can be multiplied together to give you 32. So I start to make a list here. We have 1 and 32, 2 and 16, 4 and 8. So these are all smaller numbers. They're called the factors of 32. Let's take another look at a number like 12. And here I made a list of the factors of 12. 1 and 12, 2 and 6, 3 and 4. So those are all the numbers when multiplied together can get you to 12. So those are the factors of 12. Now, if we were to compare 32 and 12, there are 3 numbers in each list that are the same, 1, 2, and 4. So all of those numbers are factors of 32 and 12. But the number 4 is what we call the greatest common factor, the biggest number that is common to both. So let's think about an exponential expression. What if we have something like x to the power of 5 or x to the power of 8? These expressions are a result of multiplying x 5 times and 8 times respectively. So there's 5 x's in the first expression and 8 x's in the second expression. So the greatest number of x's that can be factored out of both of those expressions is 5 x's. So here it is. The GCF, or the greatest common factor between x to the 5 and x to the 8, is x to the exponent of 5. So let's take a look at some of the examples. We're going to factor these expressions. So we have 4x minus 10. And when we're trying to factor, we're trying to sort of divide out the biggest number and the most, I guess, letters that you can take out of both terms. So if I take a look at 4 and 10, they're both even numbers. So right away, we should be able to recognize, okay, I'll take a 2 out of both of them. And then if I also take a closer look at the expression, I have an x and an x squared. So I could also factor out an x. Now I can only factor out the number of x's that are in the term with the fewest number of x's. So what does that leave? If we take 4x and divide out 2x, then I'll be left with 2. And if we take negative 10x squared and divide out 2x, I'll have negative 5x. Okay, so we've split apart that expression into 2 smaller parts called factors. Let's try another one. So here we have 25x plus 10x cubed. Between 25 and 10, they're not both even numbers, but they are both multiples of 5. So I'm going to take a 5 out, and then I have 1x here, and then 3 x's over here. So the greatest number of x's that I could take out of both of those terms would just be 1. So I'm going to factor out the 5 and factor out the x. So what does that leave me? If I have 25x, but I factor out or I divide out 5x, I'll be left with 5. And then if I have 10x cubed and I factor out 5x, I'd be left with 2, and I'd have 2 x's left over. So 2x squared. Okay, let's take a look at a few more. So again, we're looking for a common factor. What can I take out of all three of those terms? Again, we see that they're not all even numbers, so I can't take out 2, but they do look like they're all multiples of 5. So let me go ahead and factor out 5. So I put it out here on the outside. And all three terms don't have an x, so I can't factor out any x's because it's not common. So 25x squared divided by 5, that would leave me 5x squared. And then 10x divided by 5, that's going to leave me with 2x. And then 5 divided by 5, that's going to leave me with 1. So here's the factored form of this expression. Now, sometimes we'll have a combination of different letters, but the process is still quite similar. We have 16 and 24. So the greatest common factor out of those two is going to be 8. So I can divide out an 8. Then we want to take a look at the x's. I have 3 x's here and 5 x's here. And I can only take out the most number of x's in the term that has the least number of x's. So in this case, we have x to the 3. So that is the most number of x's that I can take out, x cubed. And then we take a look at the y's, and there's 2 there and 2 there. That's common to both. So I can go ahead and take out y squared. Now what's going to be left over? So 16x cubed y squared is going to cancel out all of those variables, the x and the y's, but 16 divided by 8 is 2. Then we have 24, x to the power of 5, y to the power of 2. So 24 divided by 8, that's going to leave me with 3. And then x to the power of 5 divided by x to the power of 3, that's going to have x to the power of 2 left over. And then y squared, and we took out the y squared, so that's it for this one. This is the factored form. So again, we're just working on common factoring. There's no letter that's common to both of these terms, but there is a 4 that's common to both of these terms. So I can factor out the 4. And in the first term, 4b divided by 4 would be b. And then in the second term, negative 4 divided by 4 is negative 1. And then this example, 6n squared minus 9. Again, no n's are common to both terms, but there is a 6 and a 9. So we have a 3 that's common to both terms. And 6n squared divided by 3 would leave me with 2n squared. And then negative 9 divided out of 3 is going to give me negative 3. All right. So since we consider factoring like the opposite of multiplying, you can expand your answers from factored form to see if you can go back and get the original question. So we'll just do a couple and we'll check them. So for A, we have 4st minus st squared. And if I were to take a look at what is common, I have an s in both terms, and then I have at least one t in both terms. So factor out an s and a t, and 4st divided by an st, that would leave me with 4. And then negative st squared divided by st, that's going to leave me with 1t. So that's our factored form. I'm going to bring that down here to our check section. And we're going to go ahead and expand this and make sure we can get right back to the original equation. So we use our distributive property from the last couple of lessons, and st times 4 is going to give me 4st, sorry, and then st times negative t is going to give me negative st squared. So we are able to get the factored form right back to the expanded form and vice versa. So here we have those combinations of numbers and letters. So let's go ahead and see what is common. We have coefficients of 5, 10, 15. And so it seems like I can take out a factor of 5 for all of them. And then we have x terms. We have x squared here, and x here. So it seems like the greatest number of x's that I can remove is 1. And then we have 1y in the first term, 2 y's in the second term, and 1y in the third. So it also seems like I can only take out 1y. What do we have left over? Well, 5x squared y divided by 5xy is going to give me x. And then negative 10xy squared divided by 5xy is going to give me a negative 2y. And then negative 15xy divided by 5xy is going to give me a negative 3. So let's take this factored form down and let's check it just to make sure. So 5xy minus 2y minus 3. And again, we recall the distributive property. So 5xy times x is going to give me 5x squared y. Then 5xy times negative 2y is going to give me negative 10xy squared. And then 5xy times negative 3 will give me negative 15xy. So that goes back and it matches our original problem. All right, 2 more examples to just check. If we take a look at 18, a to the 5, b to the 4, c to the 3, minus 24, a to the 3, b to the 2, and c to the 2, then out of the coefficients, we can take out a factor of 6. Let me zoom in here. If we take a look at the a's, it looks like out of the 2 terms, I can take 3. That's the maximum number of a's that I can take out. As far as the b's go, 4 in the first term, 2 in the second. So it seems that I can only take out 2 b's, so b squared. And then similarly, c cubed is in the first and c squared is in the second. So it also seems like the biggest common factor I can take out of the c's is c squared. All right, so 18, a to the 5, b to the 4, c to the 3, divided by 6, a to the 3, b squared, c squared, is going to leave me with 3a squared. And then b, it's squared, and then c. And then negative 24, a to the 3b squared, c squared, divided by 6a cubed, b squared, c squared, would leave me with a negative 4, and all of the other variables cancel. So there we go. Go back and check and just be careful with all of the exponents. So 6a cubed b squared c squared times 3a squared b squared c minus 4. So 6 times 3 is 18. This a times a squared is going to be a to the 5. B squared times b squared is going to be b to the power of 4. And then c squared times c is going to be c cubed. And then 6a to the 3 b squared c squared times negative 4 is going to give me negative 24 a cubed b squared c squared. Good, so I was able to get back to the original question. All right, so let's take a look at something a little bit different. And a common factor can always also look like a common bracket. So let's take a look at an example so you can see what I mean. If I take a look at the expression of 5 times x plus 2 plus 4y times x plus 2, what's common here is not a number or necessarily a letter, but this entire bracket of x plus 2 is in the first term and it's also in the second term. So that bracket is common to both terms. So which means I can factor it out here. I'm removing it from the first term and from the second term. And now we'll see what's left over. So 5 times x plus 2 divided by x plus 2 is going to leave me with 5. And then 4y times x plus 2 divided by x plus 2 is going to leave me with 4y. So this is what I mean by a common bracket. It's not necessarily just one letter or just one number, but it's a combination inside the brackets that are the same, and it allows you to factor out the bracket. Let's do a couple more examples. So for b, I have 4 times a minus b plus 3a times a minus b, and we see that the bracket of a minus b is the same, so we can factor that out. And then what do we have left behind? We have this 4, and we have positive 3a. So we're left with 4 plus 3a. Taking a look at this example, we have p plus q, and we have p plus q, so that's a common bracket. I'm going to take that out, p plus q. And what I have left over is this p and this negative 5. And there's your factored form. Next example, we have x plus 2 and x plus 2. So I can factor out the x plus 2, and I'll have left the 5 here and the 4y here. So 5 plus 4y. So those are some examples of common factoring. The next thing we're going to do here is take a look at grouping. And so grouping is another method to use when factoring polynomials. When you're given a 4-term, this is when you know you're going to be grouping 4 terms in a polynomial. It's helpful to separate the terms into 2 groups and then find the common factor for each of the groups. So here's an example. For A, we have 12x cubed plus 2x squared plus 30x plus 5. So no common factors there. There's no x's that are common to all 4 terms, but we recognize that there's 4 terms, so we decide we're going to group these. Once you group them, you look for a common factor. So first, I'm only going to focus on this bracket. So between 12x cubed plus 2x squared, I can at least take out a 2, and I can take out a x squared from both terms. So what's that going to leave? 12x cubed divided by 2x squared is going to leave me with 6x. And 2x squared divided by 2x squared is going to leave me with 1. Now I'm going to focus on the second group and take out a common factor between positive 30x and 5. So for here, it seems like I can take out a positive 5. Can't take out any x's because in both terms do not have x's each. So 30x divided by 5 will give me 6x, and then 5 divided by 5 is going to give me 1. So now this is what we're looking to see. Now again, we have a common bracket. In each term, we have a 6x plus 1. So we can factor out that common bracket, which is 6x plus 1. And what do we have left over? Well, in the first term, we have 2x squared, And in the second term, we have 5. So we'll have 2x squared plus 5. So let's take a look at a different example. And here again, we have a couple of terms. We have 4 of them, and we don't have anything common to all of them. And so the first thing I want to do is start by grouping them. And now I'm going to focus in on the first term, the first bracket, and I'm going to factor that. So between 5m squared t minus 10m squared, I can factor out a 5, and I can also factor out an m squared. What does that leave behind? Well, 5m squared t divided by 5m squared leaves a t, and then negative 10m squared divided by 5m squared leaves a negative 2. Now, what can I take out of the second bracket here? Looks like I can take out a t. So I'll take out a positive t. What's going to be left over is t minus 2. We then have our common bracket here and here, t minus 2. And so I'll pull that out. T minus 2. And what's left over is this 5m squared and this t. So 5m squared plus t is left over. We're going to do a couple more examples. All right, 4 terms here. Let's group them. This one's a little different because we have a negative sign, so watch how this works. So I split them into my groups. I'm going to work with my first bracket, and so it looks like I can take out a factor of 3 as well as 1x. So 3x squared divided by 3x, I'm going to be left with an x, and then negative 9x divided by 3x is negative 3. Now, let's focus in here. I have negative x plus 3. Whenever you have a negative sign right at the beginning, let's think of removing that negative sign. So the first thing I want to do here is I want to factor out a negative 1. What does that do? Well, it changes all the signs of the terms that are left inside that bracket. And only by factoring out that negative 1 did I end up with the common bracket of x minus 3. So we'll pull x minus 3 out of both terms, and we'll be left with 3x minus 1. Good, we have lots of variables in this one. Let's group them. Work on the first bracket. What's common is a w, and I'm left with x plus y. And then over in the second bracket, what's common is a z, so I will pull out a z, and I'll be left with x plus y. There's my common bracket. So x plus y can be factored out of both terms. And then what's left over is this w and this z. So w plus z. Great. We'll just end this with this one last example, and we'll group first 2 and the second 2, and we'll look to common factor for the first one. And I can take out a 5, and I can take out n squared. What's left over is 1n, and then a minus 2. Over here with the second bracket, I have 3n minus 6, and it looks like the only thing I can take out here is a positive 3. That's going to leave an n minus 2. And there's my common bracket. So n minus 2 is the first common factor, and then I have 5n squared plus 3. All right. So factoring can be confusing for many students. You want to do as much practice as you can. We have different methods of factoring in the upcoming couple of lessons, but let me know if you have any difficulty or if you want to do some more practice. All right, bye for now.